This video is all about just a little refresher on using sheets to do a lot of math stuff for us. Now, I know that you can do this on your own. You can do it with your calculator, but we're going to have sheets do a lot of this work for us. So there's a few things that we're going to do and kind of let sheets take care of it for us. The first one is creating equations. Now, in IED, you did averages and things like that, but we could even make our own custom formulas. So the way we do that, we're going to hit equals. So that lets Sheets know that we want it to do some sort of a calculation. And we can type in numbers, or we can identify different cells that we can pull. So this one's our total distance traveled, which is essentially your final position minus your initial position, right? So my final position is up here, 95 minus initial position, and I can hit enter. And why that's really unique is, let's say you screwed up for whatever reason and you're like, oh shoot, the initial position was actually 82. If we change that, then that automatically changes the number right there as well. Now, another thing that Sheets does is it will predict what the next set of numbers should be. So for our racers, we know we should be 5, 6, 7, 8, on and on and on and on. So if we select all of these racers right here, and we grab this blue dot to bring the formulas down, it will try and predict what you want it to have there and automatically do that. And this is super handy if you have a lot of data sets. Okay. So now let's do another custom little equation. So if we want to know the average speed of each of these racers. So we have a sneaky little equation over here that speed is a distance over a time. So we know that the distance for all of our cars or whatever is 9. And our time is going to vary based on the racer, right? So let's create that equation. So let's go equals the distance traveled, the slashes are divided by, and then time t for racer 1, is F5, is that 4.5, and I'm going to hit enter. So we know that the speed of that racer is 2 meters per second. That's pretty good. So let's try the same thing, and it's not quite going to work. Let's see if we can copy that formula all the way down. And we run into a problem. Actually, it suggests something for us, which is pretty cool. So notice, I'm going to ignore the suggestion just for right now. Notice how, get out of here. When we click on that, it says C7, F5, which is right. So this is C7, this is F5. But when we go down, we say C8, F6. So it looks like every time we go down one of these cells, it also goes down one of these cells to kind of match up. It's trying to predict what we want. But that's not what we actually want. What we want is for that C8, or excuse me, that C7 essentially to remain stationary. We want that 9 to be pulled for all of these guys. So the way we do that is we're going to put exactly like they predicted we wanted. We're going to put some dollar signs on each of those guys. And I wonder if it'll work if I just drag it down right now. Hey, that's pretty good. Right? So C7, F5, C7, F6, C7, F7, right? So it's keeping our C7 the same, and it's just changing the time as we go down here. Okay. Not too shabby. Now that I've figured out my average speeds for all of these, let's do our last one right here. So we want to create a graph based on time and displacement. And we're not given all the information. It looks like we have 5-second intervals. So instead of typing 15, 20, 25, 30, I'm just going to highlight those and drag it down, and Sheets will predict what I want. And then we have our displacement. So we're going to take all of this data, and we're going to put it into a graph. So I'm going to select everything, including the labels. And we're going to go up to Insert, Chart. And we're going to have a little bit of fun with this. So we want not a line chart, actually. We want a scatter chart. So I can kind of see what that trend is going to look like. Let me move it just a little tiny bit. Okay. And we want to make sure that there are a few things going on here. So we have our title, displacement versus time. We have our units. And this automatically created the units in the right spot for us. So time is on the x-axis. That's our independent variable, and our displacement is on the y-axis. That's our dependent variable. Now we can change this to whatever we want to. Notice how it's going X and then Y for our data. So you may have to rearrange some things to make that thing happen. Maybe scatter point is not the way to go. Maybe you actually want to go back and do a line chart right there so we can see everything a little bit easier. And there's a lot of customization that you can do if you want to change what the axis titles are. So notice how we go chart title axis. Let's click on chart title and let's just say like, I don't know, graph of car data. I don't know, something like that. And the X and Y axes are good, but if you ever want to change those, we can go to horizontal and vertical, and we can change those as well. So with all of this stuff, you're going to put these skills to use with our dog bone data. So instead of calculating it a million billion times, you're going to use some Excel formulas to do it for you.